Good morning class. I am Kumar Kanar, your chemistry teacher. So today we have to start isomerism. The topic is isomerism. So how are you children? Fine. Okay, I am also fine. So today's date is 20th May. 20th May 2025. So now we are going to start the topic isomerism. Anybody knows what is isomerism? Okay. Now we are telling we have to start the topic isomerism. So, what is isomerism? The word iso means same and merism means the word which is formed, the word which is derived from. Okay, now we have to study what is isomerism. Isomerism is two or more than two compounds have possess same molecular formula but different physical and chemical properties are called isomers, and this phenomenon are known as isomerism. Okay, now isomerism is two or more than two compounds, two or more than two compounds possesses same molecular formula, same molecular formula, but different in but different in physical and chemical properties. But different in physical and chemical properties. Are called as isomers, and this phenomenon is known as isomerism, and this phenomenon is known as isomerism. So we have to isomerism, two or more than two compounds having same molecular formula, more than two compounds having same molecular formula but different their physical and properties, chemical properties are called as isomers. Means they have same structure, they have same molecular formula but different structure formula. Now we have to make more clear. We have to take example. So let's discuss what example. For example, we take out 6C5H12 pentane. Now we have to make up 5 carbon, 1, 2, 3, 4, 5. CH3, CH2, 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 CH3. That is pentane. And another isomerism of this compound is CH3, CH, CH3. different structural formula. And in isomerism, there is now we have to study what are the different kinds of isomerism. So isomerism is of two types. First is structural isomerism and second is stereoisomerism. Okay, we have to study one by one. Okay, so let's start.
Hmm.
So now we have to start what is isomerism. First is structural isomerism. First is structural isomerism and second is stereoisomerism. Okay. First is structural isomerism. First is structural isomerism. And second is stereoisomerism. Now we have to study one by one each. So what are the structural isomerism? They have your formula. They have same. They have same molecular formula. They have same molecular formula, but different structural formula. But different structural formula. So these are called as structural isomerism. And in stereoisomerism, they are same molecular formula but different same molecular.
चल.
So stereoisomerism is what? Same molecular formula but different orientation in space. That is same molecular formula, same molecular formula but different orientation in space. Different orientation in space, but different 3D-dimensional orientation in space. What? 3D-dimensional orientation in space. 3D-dimensional. 3D-dimensional orientation in space. They have same molecular formula but different three-dimensional orientation in space. Means a 3D molecule is there and they have a 3D molecule. So they have arrangement of atoms are different in space, a different orientation in space. See, their 3D molecules are there and their orientation are different in space. So now we have to study one. We have to study one by one what is the different types of structural isomerism. Okay. So structural isomerism is of four types. First is chain isomerism, second is positional isomerism, and third is functional isomerism, and fourth one is meta-analysis. Okay. Now we have to study one by one each. The structural isomerism is of four types. Okay. First, second, third, chain isomerism. First is chain isomerism, second is positional isomerism. Second is positional isomerism, and third is functional isomerism. And last one, fourth is metamerism. And stereoisomers is also of two types. First is symmetrical isomerism and second is optical isomerism. First is geometrical isomerism and second one is optical isomerism. Okay, now we have to study first what is chain isomerism. The chain isomerism is same molecular formula but different structure formula in carbon skeleton. Carbon skeleton means the chain of a carbon again. Means the chain of carbons. Okay. Chain isomerism is same molecular formula. Same. MF means molecular formula. Same molecular formula but different. But different structural formula with carbon skeleton with carbon skeleton. This is known as chain isomers, and this phenomenon is known as chain isomerism. Okay. Now we have to take examples of chain isomerism. Okay. Let's example. Example we have to take in C5H12. In C5H12, there is a three types of isomers. Okay, first isomers is a 5 carbons are there. In two isomers, they have 4 carbons are there, and in three types of isomers, 3 carbons are there. So let's see example one by one each. So there are 1, 2, 3, 4, 5. CH3, CH2, 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 That is called as pentane. That is called as pentane. And that is second is called as isopentane. Third one is neopentane. Second is isopentane. they are chain isomerism. They have same molecular formula but different in structural formula. Since they have pentane, they have isopentane, and they have also neopentane. Okay, so now we have to study what is positional isomerism. Okay, so let's see what is positional isomerism. Positional isomerism. The positional isomerism is defined as same molecular formula, same length of carbon chain, but different in their position of a substrate. Okay. Now we see same molecular formula, same length of carbon chain, same length of carbon chain, but different in their position of a substituent, but different in their substituent. Okay, they have same molecular formula, but same length of carbon chain, but different in their position of a substituent. So in position of isomerism, there is a difference in position of a substituent. Now we have to take example to understand more clearly about positional isomerism. We have to take example. Now example. We take C5H8O. Now we take example C5H8O. Example of C3H8O. C3H8O. That is propyl alcohol. So there are types of two isomers are there. We have to take CH3, CH2, CH3, O. So there are propane one or there are CH3, CH2, CH2, OH. Okay, so they are known as propane one or. These are propane one or. Now we have to second isomers of this compound is CH3, CH2, CH, OH, CH2, CH. Example of this compound is propane to water. CH3, CH, OH, and CH3. So that is propane to water. now we have to study next what is functional isomerism. Okay, the functional isomerism is same molecular formula but same molecular formula, same structure formula but difference in their functional group. So these are known as functional isomerism. So let's see. Now we have to study what is functional isomerism. Functional isomerism is have same molecular formula but different functional group. Is have same molecular formula. Is have same molecular formula but different functional groups. But different different functional groups. Okay. Now we have to take examples to make more clear about functional isomerism. So we have to take example. An example of functional isomerism. There is C3 at 6 4. Okay. Chain of CS3 CS2. Just to know what different functional groups are there. So what is functional group? A functional group is to give the chemical properties to any of the other compound. It is known as functional group. So we have to take example of functional isomerism to take more clear about functional isomerism. Okay. So we have to start. For example, C3 and 6. An example of aldehyde. Okay. So CS3, CS2, CHO. That is propanol. That is propanol. That is propanol. In that way, this compound has molecular formula. This is known as C3SH4. So these are aldehyde. These are aldehyde. In aldehyde, we have to retain this. Okay. For ketone, we have to retain this. In ketone, we have to CH3, C double bond 4, CH3. So they have in aldehyde form and we have ketone. Okay. We have to take another example of that functional isomerism. Okay. That is alcohol and ether. CS2 OH then CS2 form is C2H5OH. Now we have to take example of ether. In ether we have to take CH3O CS2 CS2 OH. Take CS3 Yes. They have same molecular formula, that is C5. Uh, they have molecular formula of C2 HCl. So they have also wrong. They have wrong here. So they have a molecular formula of C2H6O. C2H6O. Okay. Now you can see that in both of these, in alcohol and ether, okay, they are in alcohol. There is a high boiling point because of their hydrogen bonding, and in hydrogen bonding, the ether is get evaporated. Okay, so because ether have no hydrogen bonding, okay, so they have hydrogen bonding. So in both they have same molecular formula, but difference in their functional groups. Like we have seen, there are alcohol and there are ether. Okay. What is metamerism? Okay. In metamerism, they have same molecular formula, same structure formula, but different in their different methyl group surrounding their functional group. Methyl groups are present surrounding of their functional group. Okay. Now we have to let's see. Metamerism is what? Same molecular formula. Same molecular formula. Same structure formula. Same molecular formula. Same structure formula. Same formula and same functional group. Same molecular formula and same functional group. Same functional group, but methyl group in the surrounding of their functional group, in their surrounding of their in the surrounding of their functional group. Functional group are changes. Okay. Now we have to study example metamerism. So then more clear about metamerism. Okay. We have to take example. There is a chain of a carbon here, CSP, CSP, O, CSP, there is a 5-chain-like structure. So there is a 5-chain-like structure. Okay. Now we have to take another isomer. CH3O, CH2, CH. CH2. This is also CH2. Also CH2 and that is CH2. C4H10O. This is example of C4H10O. Okay. In these two mechanisms, they have in second they have one methyl and one ethyl groups are there in the surrounding of oxygen atom. Okay. In first isomers, they are surrounding with two ethyl groups are there in between the oxygen atom. So they have same molecular formula, same function groups are there, but methyl group in the surrounding of their function groups are there. The methyl groups are in the surrounding of function group are changes. So these are known as metamerism. Now we have to study next what is stereoisomerism and their types of geometrical isomerism and optical isomerism. Optical isomerism we have to study class 12 and geometrical isomerism is there. So we have to study. Geometrical isomerism. Geometrical isomerism, there is a double bond and there is a triple bond. Okay. Here, in a two carbon there is a single bond. In the single bond in two carbon, they have a free rotation. Since they are rotation is possible. Okay. In double bond, the rotation of a carbon is not possible. Now we see the two carbon are there. So there is a single bond is there. In a single bond, there is a rotation around the carbon bond is possible because there are three. In double bond, there three rotation are not possible because of PPO constants. Like C has double bond in carbon, they have PP overlapping are there. So since in double bond there are not rotation is possible. Okay, like the example that is called as a ethane molecule. That is ethane molecule. Okay, now we have to take example. Okay, an example. We have to take two carbon which is double bonded. Okay, we have to take and diagonally the methyl compound. The methyl groups. Okay, in diagonal we have to take methyl groups are there. There are hydrogen. Okay, another we have to take there. Okay, carbon double bond carbon. That is hydrogen, and that is CH3, that is CH2. Okay, in there two methyl groups are located in their diagonals of their carbon. The two methyl groups are located in their diagonal position. Okay, so there are transform. So there are transform. The methyl groups are located in their diagonal side. So these are known as transform. These are these are trans. Okay, and in this, the two methyl groups in this, the two methyl groups are located in the same side of the atom. Okay, so these are known as cis. So these are known as cis. So in a geometrical isomerism, there is a two type, that is cis and trans. Okay. Now we have to end today's class. Thank you.